We're burning too much carbon, which puts us in the midst of a global warming meltdown. But help is on the way. Just as we've created the problem, we're creating the solutions.
We now realize that technology is actually what's going to solve this problem for us to a large degree.
And it can be done on a small scale. Windmills are nothing new. But this one on top of Jay Leno's 16,000 square foot garage has a secret. It doesn't care which way the wind blows.
I think the really cool thing about it is you're utilizing something that was always been here, the wind. You're not changing it, you're not altering it. There's no byproduct of the wind. The wind is going on 24 hours a day. And then since we're right near the airport, every time a jet takes off, 100 watts!
Supplying Leno with ample wattage is Phil Watkins, inventor and owner of PacWind Incorporated. To him, harnessing the wind is not only a passion, it's the future of home energy.
You can actually see the energy being made, and just kind of a thrilling experience, you know. You look up, you know the wind's blowing, and you say, okay, am I making any electricity? You can run over to the meter, you can see it happening.
What's happening is wind being used to drive a turbine that produces electricity for immediate use. When the electricity isn't being used, it can be stored in a battery for later. Windstorms are welcome. Traditional wind turbines, those propeller-driven giants perched in windy areas, are capable of producing several megawatts. But to drive them, the wind has to hit them just right.
Imagine this is a propeller, and the propeller is spinning around an axle, okay? Well, in order for the propeller to spin, the wind has to interact with the face of the blade. If the wind is coming from this direction, that means the blade has to turn in that direction for the wind to interact with the foil and cause it to turn.
Making wind turbines for the home is a matter of design. Using lightweight composite material, PacWind is making it possible to put wind power on the roof.
The vanes in the vertical axis can accept wind from any direction. We can catch wind in this area here, or in this area here, or in this area here. Any one of these surfaces we can catch the wind from.
When it comes to performance, PacWind has more ways than one to grab the wind.
Essentially, you're looking at two machines that will produce about the same amount of energy. This one is spinning at a slower speed, but it has a lot more cross-sectional area to it. So that means more area means more power. On the other hand, making power is also a function of speed. So the faster you go, the more power you make. So essentially, they'll produce about the same amount of power.
In this 10-mile-per-hour wind, these turbines are churning out approximately 250 watts, or about a combined television and refrigerator's worth. Multiply that by a city or a state, and billions of tons of greenhouse gases will never blow into the atmosphere. And then there's the Mondo version, for those homes in need of a really big jolt. Like this one, on Jay Leno's 16,000 square foot classic car garage.
I don't want to take anybody else's energy. I'd like to make all my own energy myself. I'd like to make as much as I want.
So while PacWind founder Phil Watkins installs the turbine, electrician George Thomas connects it to the power grid. Add in some solar panels and let the savings begin.
Switch on, switch on.
Okay, we're reading good, right?
We're reading good.
Okay.
Any energy that's not being used is being fed back into the grid. If the lights are off here during the nighttime and the turbine takes off, this thing can spin back at 10,000 watts all night long. And so you can literally spin the meter backward.
Anytime you give power back, well, that's great. I mean, obviously, if we can run the lights, we don't do a lot of heavy work in this building. It's mostly just lights and air conditioning. So if we can get most of that from solar and from turbine, then it's great.
Not to mention satisfying.
It's like, why does tomatoes grown in your backyard taste better than tomatoes you buy at the store? And why does electricity you make yourself seem better than electricity you buy from the city? It's just because you had a hand in it.
What if you put your hands on it? That's what you can do with another green choice that's available for the home. It's a real killer called the green switch, and it's after the vampires in your house that are robbing you blind.
There's vampire power that's actually
sucking energy from your home when you don't even actually have appliances on. In the off mode, they're still drawing power.
Walk around your home at night and look at all the little red lights that are flashing. You'll be amazed. And it's one way to discover how many of the appliances are actually sucking energy and money out of your wallet every single day.
According to the Department of Energy, those little red lights represent between 10 and 15% of all the energy used in an average household. And they just sit there taunting us.
This is a typical home office environment. Maybe you have a printer, internet modems, stereo or an iPod. If you look here at the monitor, it's using 19.2 watts. All this equipment in standby mode, so you're completely wasting energy. It is not good for the environment, and it's definitely not good for your wallet.
And let's not forget the most powerful vampire of all, the home entertainment unit.
As you can see, all of this equipment is on. This is the standard stuff that you would have in your home: DVD player, cable box, and television. It's drawing about 100 watts. If I turn them off, that number will drop down to about 26 watts. So even in the off mode, you're still drawing 26 watts, or 25% of the normal power it would take.
In the home, it's just a matter of deciding which vampires you want to kill. After you've identified the bad guys, the first step is to install a green switch slave receptacle to the outlet.
This is our slave receptacle. Once you've established where you want to put this in your house, the installation is very simple. This is the antenna. This receives the signal from the master switch. It tells this unit whether to turn on or shut off.
Receptacles can be wired to as many outlets as you choose, as well as your air conditioning thermostat. Then, once the receptacles are installed, they lay in wait for a signal from their master switch.
We're at the front door of the residence. We've already gone through and replaced all the other switches and receptacles that are going to communicate with this green switch. I've removed the existing electrical from this box here, replaced it with a new toggle and our green switch. It all wires into the existing electrical. It's a very easy installation.
Now flip the switch and all those energy-sucking vampires are put to rest. Money is saved, and the environment receives less pollutants. Of course, if you really want to get obsessive about your energy consumption, try the power cost monitor. Just wrap a sensor around your outside meter, and this in-your-face device lets you watch the watts, cash, and environment burn away. Green switch, anyone? And then there's the trash.
One of the biggest single sources of greenhouse gases and other pollution to our atmosphere are landfills. They decompose over time, creating methane and other greenhouse gases.
In urban areas, as much as 40% of all trash is food waste. But there's a company that wants to make sure it never gets to the landfill. It's Nature Mill, and its indoor composter is the magic box that disposes your garbage to your garden.
Pretty much any food waste will go in. Any of these shavings, organic stuff, coffee grounds, tea bags. So what we're doing is we just put the food waste right in there, and in it goes.
To make compost, food waste needs the proper amounts of oxygen, moisture, and heat. If left to nature, this process could take months. The indoor composter supercharges the oxygen levels and temperature, speeding up decomposition to about 2 weeks. All for 10 watts of power, or about 50 cents worth of energy per month. The composter can gobble up to 5 pounds per day, the amount of food waste thrown away by a typical family of 5.
So after about a week, this is what it looks like. You can see it's starting to turn into compost, and you can keep adding more. It all mixes in there.
After it begins to break down, the mixture drops through a trapdoor and into the bottom chamber. There it cures for another week and begins to dry out. Now, if the thought of decomposing food puts a tingle in your nose, fear not. The designers have it covered.
So we put an air filter inside the machine, which is always on, and it's located in the back here. You can see that air passes inside these holes through the activated charcoal and then out the filter. And this air filter should last about 5 years.
No smell, no mess, no need to build new landfills. Just open up the tray and the final product is ready for its close-up.
So normally, all this great organic waste goes into landfills, but here it's being turned into compost, and after just 2 weeks, you've got rich organic compost. You don't have to have a diesel truck come and take it away, and it's really great for your garden.
Compost or no compost, the gardens in Azusa, California are wilting under another 100-degree day. And inside the public library, the air conditioning is doing double time.
The library receives maybe 500 visitors a day that come in and out of the library, and a lot of them do come in as a refuge to get away from the heat.
Chilling out in this heat pushes the city power grid to the max, threatening blackouts and prompting calls to build new power plants. But city officials have found ways to relieve the pressure, like using energy at night to cool their library during the day. Sound tricky? Well, it's all in the ice. The Ice Bear cooling system.
This is essentially just a large tank of water. What we've got here is a 500-gallon tank, and inside it we have these copper coils that really, if you look close, kind of look like a mattress spring that's been stretched to 5 feet tall.
Inside those coils is where the Ice Bear performs its first trick. At night, a pump sends cool refrigerant through the coils in the water. The water freezes into a block around the coils.
Right now it's cold to the touch because we actually have ice that we've frozen in here during the night. I'm actually tapping the ice right here.
During the day, when the air conditioning unit is turned on, the pump sends warm refrigerant back through the coils and through the ice. That refrigerant is chilled and then pumped through pipes into the existing air conditioning system to provide cooling. At the end of the day, the Ice Bear goes into hibernation until later that night when the process begins again.
We'll be able to provide about 8 hours worth of cooling out of this ice. And then again, it will all be water, and we'll use the condensing unit again to freeze it into ice.
By getting its energy at night instead of mauling the power grid during the day, the Ice Bear can put the deep freeze on greenhouse gases by using cheaper, cleaner nighttime energy.
A lot of places are now generating renewable energy at night with wind. So by moving some of that demand to the nighttime, you're also moving some of that demand to cleaner sources of energy that help the environment.
This technology is so simple. It's a huge block of ice that is outside our library, and somehow it's working to keep this building cool.
How's this for cool? A solar tower that can electrify a city and is hotter than the planet Mercury. In the desert outside Seville, Spain, 360 feet of green technology is catching some rays. It may be the method that brings a massive infusion of solar energy to our cities. It's called a solar tower, and it stands as a beacon of hope in the fight against global warming. The top of the concrete tower basks in the reflection of a sea of mirrors called heliostats. The heliostats are spread over 170 acres. And every day the sun shines, it turns the tower into an oracle of solar energy. Valerio Fernandez is the plant's engineering director.
We are at the middle of the heliostat field of Piastén solar plant. It is composed by 624 heliostats that are composed by mirror. The function of the heliostats is to reflect solar radiation. These units are not hot.
The heliostats are programmed to keep the heat on the tower from dawn to dusk. As the Earth turns, the heliostats move in accordance, staying perfectly focused between the sun and the tower.
There's years that have 29 days in February, so all the years are different. The equations to reflect very accurately the movement of the sun are complex and have to be updated every several years.
Each heliostat is made of glass and steel, with a surface area of 1,300 square feet.
They are made of mirrors, conventional mirrors, that reflect solar radiation, and they are slightly curved in order to concentrate solar radiation towards a point that is the receiver that is placed in the top of the tower.
Under the force of all the mirrors, the solar receiver reaches temperatures of 1,000 degrees Fahrenheit. That's hotter than the daytime temperature on the planet Mercury. The receiver is made of 4 steel panels. Each panel is an array of pipes welded together. Within the pipes is water. When the sun hits the panels, the water is heated and turned into steam. Pressure created from the steam's expansion drives the turbine, which creates electricity. Once that electricity moves into the power grid, the process is complete. The sun's heat has been successfully harnessed and turned into clean energy. This single tower provides energy for 6,000 homes. But the Spanish aren't stopping there. They're building more towers. In fact, they've planned a total of 9. The entire project will produce enough power for the 700,000 residents 12 miles away in Seville. This spark for tower technology was ignited in the California desert during the 1980s. Built as a full-scale prototype, Solar One harnessed the power of 1,800 mirrors, all aimed at the top of a 295-foot tower. But instead of using water as a heat conduit, Solar One used oil. For 4 years, the prototype sporadically produced up to 10 megawatts of electricity, enough to power about 5,000 homes. But more importantly, it proved the technology worked.
I don't think anyone believed that there would be so many days and so many kilowatts of energy generated. It actually exceeded all of the estimates that were initially done.
Back in Seville, Spain, engineers chose water as a heat exchanger. But there's still one major challenge to overcome: how to keep the turbine consistently spinning when it's dark.
At this moment, our first plants have only a very limited storage capacity of thermal energy that allows us to produce electricity when there is no sun. But this is limited to about 1 hour.
The trick is in how to keep water hot enough during the night to produce the steam that drives the turbine. So engineers are looking at hybrid solutions, like wind power and biofuels, as ways to keep the clean energy flowing 24/7. Still, the Spanish solar tower is glowing with success. When the sun shines, the tower produces a daily dose of 11 megawatts of electricity. And it's done without a single puff of greenhouse gas emission.
With this successful commercial plant, I think we did the very successful first step.
The proven long-term success of the Spanish project has created a solar tower awakening. From China to Morocco, tower power is beginning to capture the attention of investors and government officials. But not all solar towers are created equal.
There's yet another very interesting solar thermal technology. That's where you simply take an upside-down funnel and allow the sun to pound on that funnel all day long.
Not surprisingly, the funnel model was first tested in eco-friendly Spain, just outside Madrid, in sun-drenched Manzanares. The project was based on a simple principle of physics: hot air rises. The plant started with a massive greenhouse. A clear polymer canopy, or collection area, surrounded a 630-foot tower with a hollow bottom. As the sun beat down on the canopy, the air underneath was heated to 95 degrees above the ambient temperature. The heated air moved toward the cooler air at the top of the tower. That updraft funneled through a large turbine stationed inside the tower. The plant operated from 1982 through 1989 and put out 50 kilowatts. Not much, but it worked. The design seemed ready for its day in the sun. But in the late 1980s, oil was cheap and interest chilled.
We've learned that there's a couple of things that drive investments in solar towers. One is the cost of oil. The other thing, of course, is government policy.
Now, with oil prices at record highs and environmental issues burning in the public's consciousness, interest in the Manzanares model has reached critical mass. An Australian firm called Enviromission plans to take a new tower to unprecedented heights.
It will be one of the largest structures, if not the largest structure on the face of the Earth.
The steel-reinforced concrete tower will rise 2,500 feet above the earth. That's nearly half a mile, and twice the height of the Empire State Building. Its base will be 430 feet in diameter, wide enough to provide a firm anchor during high winds. The glass and polymer canopy will span 3 miles, gently sloping from a height of 6 feet at the perimeter to 100 feet at the tower. There, 32 jet-sized turbines will be waiting to take the hot air and turn it into electricity. The tower promises year-round energy.
Greenhouses still operate in winter, so they still collect warm air. You still create a temperature differential. You may not have the huge output you have in summer, but you will certainly have a very substantial output.
Enviromission believes their tower will light up the power grid with an astounding 200 megawatts. Even if the tower runs at 80% capacity, that's enough power to fuel 500,000 households. Enviromission has already purchased a 20,000-acre site between Melbourne and Sydney.
It'll be an engineering marvel and obviously a renewable energy icon.
And it will be expensive. Estimated cost to build the tower is $700 million. It's a hefty price, but one that would eventually pay for itself.
It will be, we believe, competitive in output with coal, but it is more expensive to build, but it costs nothing to run.
With investment capital rushing toward green machines, that $700 million looks attainable. Jetson-style transport module included.
I think this is the holy grail of renewable energy. Opportunistic, yes, obviously. I mean, you don't do anything for nothing. But what was a dream became a passion. We are going to get it built.
There's another green machine that's just been built. A car that runs on air. And if its French inventor has his way, it will be the automobile of the future. Listen to the distinct sound of this pollution solution. It's a car that runs on compressed air, called a CAT for compressed air technology. It's the result of 14 years of research and development by French engine designer Guy Negre. With the CAT, Negre has created a car that produces 0 emissions.
The premise of this project was that in order to run a car, particularly in town, you need very little energy. And with compressed air, you can accumulate enough energy to do that.
Compressed air has long been used as a power source for various tools and equipment. For car designers, compressed air has been difficult to harness. But now, Negre and his team at Motor Development International have built an engine that they believe will blow the car market away. Within an internal combustion engine, gasoline and oxygen ignite. The resulting explosions create pressure, which pushes the pistons that turn the crankshaft. With MDI's engine, precisely timed bursts of compressed air create the pressure needed to drive the pistons, pollutant-free. Supplying enough energy to power the car requires pressure at 4,300 pounds per square inch. That's more than 100 times the pressure in a standard car tire. Forced inside a tank small enough to fit under the CAT's chassis, it's the formula for a potential ticking time bomb. So the pressure was on the designers to build a tank that won't explode.
This is to give you an idea of the technology inside of the car. You can see that under the floor you have some carbon fiber tanks. It has to be carbon fiber on cars because it is very safe. If there is a crash or something, there's no problem with pieces going everywhere. There's just a crack and then the air goes out.
The tanks can even withstand the force of small caliber gunfire. Since it's being powered by air, the CAT has a lightweight aluminum frame to keep it lean and nimble. The same care went into the body.
The body of the car will be made with fiberglass. Using fiberglass is very important for us because the car will be lighter, and having a light car, you will have more range. In our technology, we won't store a lot of energy. So we have to manage this energy to have a bigger range.
MDI has licensed the technology to Tata Motors, India's largest car manufacturer. And Mexico City is looking at the cat as a way to cut into its layer of smog. Once the cat leaves the factory, it will need some air. And MDI will need to convince gas stations to play along by installing industrial compressors and air tanks.
This is a compressor, and you can use this to fill some high-pressure tanks, a huge volume, and then when the car arrives at the air station, you just have to transfer the air from these big tanks to the car, and that takes just 3 minutes.
But airing up can also be done at home. Plug in a compressor that comes with the car, and in 3 to 4 hours, the tank is full. It's now ready to go 125 miles for just $2. If the air is generated with a renewable source, the car becomes a true green machine.
This is the motor alternator to fill the car when you plug the car on an electric plug to fill the tanks.
Put it all together, and the city version, or Mini Cat, will hit a top speed of 70 miles per hour. If you want a Tiger in your tank, MDI has developed a gasoline dual energy version. When the air is depleted, gasoline drives the engine while an onboard compressor refills the air tank. Alternating between the two fuels, the hybrid will hiss along for an amazing 600 miles on one small tank of gasoline. The first car targeted for early production is the Mini Cat. If you think it looks strange from the outside, take a closer look at the steering wheel.
This is why we've put the driver in the middle. Having the driver in the middle, you can put it a little bit more in front of the car, so you have more volume for the trunk. This is the basic idea. But then also for us, it's more simple to use this car in England and France, for example. There's no problem because the driver is in the middle.
Right side steering, left side steering, it doesn't matter. Guy Negre has made a car for everyone. Costs for the cats will range from $7,000 for a 4-cylinder Mini Cat to $25,000 for a 6-cylinder family car. Negre's determination to be eco-responsible extends to manufacturing as well.
We are going to expand the industrial concept we came up with, which is to make cars in small factories located within the market. It is an original concept. It's very important for the economy, for social issues, pollution issues, and the environment.
The compressed air car works. Now all Guy Negre needs is the support of the public and the automobile industry.
Breakthroughs are always difficult, especially technological breakthroughs, because the industry generally follows the direction that has already been established, and they don't like to see someone trying to change the course. But today, there is a worldwide need to change the course.
There's a worldwide need for pure water as well. Fortunately, we can turn heavily polluted water into something drinkable, but it's costing us billions. Water in the American West. There's only so much of it. But underneath one of the thirstiest regions in Southern California, there's 1 trillion gallons of it. And a lot of it is polluted, but not for long. 200 feet below the San Gabriel Valley, toxic chemicals have contaminated the aquifer. They've been here for decades.
Back in the beginning of the 1900s, the beginning of the Industrial Revolution, we thought that we could throw things away. We thought we could throw waste into rivers and waste materials into landfills or dump things into the ocean and then it would go away.
And before the 1970s, none of the laws that are in effect today were around, and practices for handling and disposing of chemicals were much different than they are today.
It took one of the worst ecological disasters in American history to force that change. Love Canal. In 1942, an upstate New York waterway became a toxic waste dump, used by a chemical and plastics company. By 1978, nearby residents were suffering with abnormal rates of birth defects, miscarriages, and cancer. From this tragedy came the Superfund, a federal program intended to identify and clean up toxic waste sites across America. For the first time, technology would be used on a massive scale to systematically clean up the environment. The San Gabriel Aquifer is one of those sites.
EPA has identified about 20 companies that we think have contributed to the pollution in this area.
The responsible parties ranged from industrial cleaning companies to rocket manufacturers. Every day, 11 million gallons, about 500 swimming pools worth of contaminated aquifer water, enters the San Gabriel water treatment plant for a cleaning.
The water is pulled out of the aquifer through 3 extraction wells, which feed this treatment plant. The water goes into the first phase of treatment, which is air stripping, through that vertical pipe going up the side of the air stripping tower. The water goes into the top of the tower, and it falls through.
The tanks are filled with thousands of grapefruit-sized plastic balls. Each ball is a porous matrix. As the water falls through the balls, it's broken up into droplets. Meanwhile, air is introduced from the bottom of the tank. When the air meets the droplets, volatile contaminants become vapor and are carried out the top of the tower.
The air with the volatilized compounds leaves the top of the tower and goes into the blue bins, which are carbon filter bins. The air enters the top of the bin, moves through the carbon bed, and then exits out the bottom and up the stack as clean air.
While air stripping removes most of the volatile chemicals, several other contaminants remain. Next on the list for removal is a potential cancer-causing agent, 1,2,3-trichloropropane.
After the water leaves the air strippers, it enters through this top pipe here into these 10 vessels, which are 2/3 filled with granular carbon, which is this material here. The water enters through the top of the tanks, goes through the carbon. Any volatiles that either were not removed by the air strippers, and as well as the 1,2,3-trichloropropane, are removed. The clean water then exits the system through this bottom line here and goes on to the next phase of treatment, which is ion exchange.
At the ion exchange station, the water flows through a series of tanks. The target here is a component of solid rocket fuel called perchlorate. If enough is ingested, perchlorate attacks the thyroid.
They're filled with the ion exchange resin, this synthetic resin. There are 30 vessels on each carousel.
As the water containing perchlorate passes through the vessels filled with resin, the resin grabs onto the perchlorate ions and replaces them with chloride ion.
One last stubborn chemical remains, the potentially cancer-causing NDMA. The best way to eliminate it is by zapping it with ultraviolet light.
This is the last step in our treatment facility. This is the ultraviolet or UV system. The water flows through here. Each one of these panels has 16 lights. The water flows through this light, and the NDMA is inactivated. NDMA is a component of rocket fuel. And this is what it looks like.
Inside the trough, the water passes through a series of 2,200 ultraviolet lights. As the NDMA molecules absorb the light, they're broken down into non-toxic components. At the end of the tank, the water gets a little dash of chlorine and then makes a clean break for the city water supply.
And here we are at the effluent of the plant. What less than 1 hour ago entered the plant as contaminated water is now drinking water, safe for public consumption.
As the clean water leaves this part of the plant, an equal amount of contaminated water will enter at the intake. It's a cycle that will repeat for decades to come.
The area of groundwater contamination is more than 8 miles long and 1 mile wide. We think it took 40 to 50 years to become that large. It's going to take as long or longer to clean the groundwater up.
To date, at this plant alone, the cleanup has cost a total of $48 million and counting. Of that, the federal government has paid about 30%. The responsible parties have paid the rest. Troubled times sometimes call for radical solutions, like a bizarre experiment that may save the world, and a new take on the age of sailing. Aboard the Weatherbird 2 in Fort Lauderdale, Florida, a crew of marine biologists is preparing for a journey that they believe will help save a sick ocean, and at the same time, help solve global warming by turning the ocean into a giant sponge. The biologists will target an indispensable element for human life: plankton. Some of these microscopic organisms can act as floating forests, gobbling up carbon dioxide from the air and returning it as pure oxygen. But the plankton beds are shrinking at a rate of 1% a year. The Weatherbird crew is determined to reverse that trend with a simple but controversial experiment.
Planktos, our company is in the business of eco-restoration. We say that we restore the trees and the seas of the planet.
The Planktos team is going to feed plankton beds with a nutrient the microscopic creatures need: iron. The more plankton in the ocean, the less CO2 in the atmosphere.
For every ton of iron that goes into the ocean, about 100,000 tons of carbon dioxide is taken out of the atmosphere by the ocean plants.
Using satellite imagery, the team has identified a pristine plankton bloom for their experiment, 300 miles west of the Galapagos Islands.
Here I have a sampling of some of the iron nutrient that we'll be mixing into the water. And this iron nutrient that we're going to be fertilizing is very fine to where when we drop it into the water, it's going to dissolve. And we want it to float on the surface for as long as possible. That way it'll draw the plankton to the surface.
Over a 2-week period, the Weatherbird crew will use a plastic tube to dump between 50 and 100 tons of iron atop the Galapagos bloom. According to Planktos, that will remove 5 to 10 million tons of CO2 from the atmosphere.
We use these mixers here. We suck up seawater into them. They can hold 300 gallons. We open this up. We put the iron in here. Motors turn on, mix the iron up with the seawater. This in turn, these tubes come to the back and we release that concentrated iron seawater mix while the boat's moving and spread it over the ocean.
After spreading the iron, a research team will stay with the bloom for 20 weeks to monitor plankton growth and to record how much carbon dioxide it has absorbed. They'll test the samples to determine how deep the CO2-filled plankton has sunk. This enables the team to put a time frame on how long the CO2 will remain out of the atmosphere.
Once we dry it, we can identify how much carbon is present in the dried biomass. And we'll do that for different depths, so we can see how much is at the surface, how much is sunk to 100 meters, 200 meters. And as it goes further down, we'll know that carbon has been sequestered for decades, hundreds of years, or millennia.
The deeper the plankton goes, the more pressure there is to hold it down and keep its carbon from rising. If it sinks below 500 meters, it will stay there for upwards of 1,000 years. And that means more money for Planktos that can be made by selling carbon credits. Yes, it's about money too. Carbon credits are a way for CO2 producing industries and individuals to offset their own emissions. By paying companies like Planktos to plant iron in the ocean, trees in the ground, or wind turbines in the sky, we might give our Earth a fighting chance. The worldwide standard is 1 credit equals 1 ton of CO2. Prices vary depending on method.
By restoring the plankton blooms that are in great decline in the ocean, we can bring that life back, and in the bargain we earn carbon credits, which pay for the whole operation. So it's a wonderful win-win situation for everybody.
Many in the marine science community disagree. To some, the Planktos project may have unforeseen consequences.
When you suddenly cause a bloom of plankton or algae to occur where it otherwise wasn't going to occur, that growth will absorb oxygen, which might rob that particular section of the ocean of oxygen for fish or other things that need to live there. So as with any genie in the bottle, we have to release it carefully if at all.
And although there's no consensus on how much carbon the ocean can hold, for Planktos, the experiment is worth the risks.
Our intention is to discover whether it's okay to do this. And of course, if it doesn't work, we won't be able to earn any money for it. And since we're a for-profit company, our investors will stop funding us and everything will come to a halt.
Other green machines on our oceans are less controversial and a little more lofty, like this German product called SkySail. It's being tested as a way to reduce emissions from the thousands of cargo ships that chug across our seas every day. The SkySail is meant to take some of the burden off a ship's engine. Tethered to the deck with a web of carbon fiber ropes, it gives the ship an added boost to pull it through the water.
You might not turn off the engines all the time, but you can certainly reduce the amount of fuel that you're burning and the number of hours that you are burning them.
Of course, to reduce engine hours, the SkySail must catch the wind. A computer attached to the towing cable reads wind speed and direction, and then guides the sail up or down to the best air. The sail can fly as high as 950 feet, where strong sustained winds prevail. Onboard computers coordinate satellite weather data with shipping lanes for the fastest route. Tests aboard the 180-foot research vessel Beaufort proves the system flies. In 10-mile-per-hour winds, the 80 square meter SkySail produced a towing force of 3 tons. That equated to a savings of 320 gallons of ship diesel per day. If the SkySail was placed on just half the 40,000 cargo ships and tankers on the sea, it would save over 2 billion gallons of diesel per year. With larger sails and higher winds, the savings would increase. When the winds die down or a storm approaches, the SkySail is hauled into a safe berth below deck. As we sail into the 21st century, we look to green machines to help save our environment.